Long ago, back in 2010, I bought a ShopBot brand CNC router. ShopBot is a company down in North Carolina, I believe, and they make kind of entry-level CNC machines. There's somewhat more affordable, although I think this one was still around $16,000 shipped. They're more now because the economy is better. But yeah, I got it back in October of 2010 when I first had my shop when we started the Ben Heck Show. And yeah, it came in a crate, just like this. It's kind of hard to believe, but yeah, very heavy crate. I had to get lift gate service for it. Then we cracked open the crate, and all the pieces were there. And the main gantry was all in one piece, which was the bulk of the length of it. And man, that thing is heavy. That's like 300 pounds. So then we set it up in the old shop on the somewhat unlevel floor, although we adjusted the feet to accommodate for that. And then we gave it a surface of plywood, which was attached with bolts to the main steel frame. Then on top of that plywood, we put a couple layers of MDF, medium density fiberboard, which is basically particle board, aka IKEA furniture material. So that was the first iteration of the CNC machine, and then when we moved the shop in 2014, I redid it still with particle board, but I gave it like a chamber, so it had like a vacuum table, and that was kind of cool and all, but I very rarely used it. So then in 2018, we finished up the show, and I moved my CNC machine into the garage of a house that I bought. It's a two-car garage, and I'm not married, so I can put whatever I want in it. And so I put in the CNC machine, and actually there's still room for one car. So what I want to do in this video is cover my plans for making table revision 3. All right, we're here in Adobe Illustrator version. Who even knows anymore? Probably actually, it's version 23. They would never tell you that, but that's what it actually is. I hate when live services just change stuff, like when you go Control R to rotate something. It used to be the amount of rotation would be selected. So you do a Control R, type in a number, right? But now you go Control R and you have to go to the number and type it in. Stupid! Don't waste my time. I need that time to play video games and drink beer. Here's a representation of the table. This is the 0, point, which is usually where I stand as the operator. Now you'll notice there's all these lag bolts drawn in as these gray circles. These are actually larger than the lag bolts. That's basically a safe keep away area. Now, if you notice, they're not symmetrical vertically. See how this front steel frame is quite a ways back from the edge of the plywood, whereas in the back, it's closer to being level. So when I first set up the machine, you have to actually manually put in the inductive limit switches, setting where the front and back of the machine is. So it's basically kind of up to you. And I remember actually that took me a while to dial in. So in this case, I had to draw in very accurately the errors in it. So see how these bolts are also not centered on the plywood. So yes, I had to make sure I had this correct because I don't want to accidentally drill into these bolts. I want to put in some TTrack, which allows you to slot in nice clamps. So this is the base that we already have, which is 3/4 inch plywood base. Then above that, I want to have the TTrack, which is 3/8 of an inch thick. Spacers, also 3/8. T-track on the side, so you could possibly put a clamp on the side, just like that, even though it looks like a Tetris block. And then on top, 1/2 inch expanded PVC foam, aka Comatex, aka Sintra. I love using that for projects. It also makes a really good sacrificial surface. It's expensive though. It's about 5 times as expensive as MDO, but it will be nicer. And then in that, there'll be a countersunk screw, which will go through the spacers and the lower 3/4 inch base. Then what you do is you make a pocket above the countersunk screw. And the reason you do that is so the screw is as low as possible while still having a grip. That way, if you need to replane the surface, you can do it a few times before you possibly hit the screw. So here's the clamp I want to try. I just ordered one of these to see how I liked it. And it's pretty nice quality. It's not super cheap, but I think it should be nice. Is there any doxing information on the screen that I need to watch out for? My zip code? Well, everyone knows I live in Madison. And here's the TTrack. So it's extruded aluminum and it has countersunk screw holes in it. It didn't say what the spacing was, but once I actually got it, I realized it's 4 inches on center, 12 holes per track, and the track is 48 inches long. So kind of pricey. So this is definitely the most expensive CNC table I've made by a long shot. So once I received the track in the mail, then I could measure it myself and know exactly the size of it, because something like this, it's listed as 3/8 by 3/4, probably actually 10 millimeter by 20 millimeter, but sometimes people fudge that. Although when I did measure it, it was actually pretty close. You see, we have a little bit of deviation. It is slightly thinner than 3/8 of an inch, which makes you wonder. Let's see, let's switch this over to every other country but America units. 18.9 millimeters wide, 9.3 high. So yeah, it's weird. It's a lot of times if you see something that, you know, is kind of on the edge, it, you know, means it's like actually metric. That happens a lot. Like if you go and you buy wood at like Home Depot or something, and they'll say it's 3/4 inch, but it's actually a little bit off, and it's actually metric. So what I did was I then put a bunch of holes in place to represent the TTrack. So the reason that this is cool is because I can actually have the CNC machine drill these holes for me. That's why I drew in the lag bolts, so I made sure none of these holes hit the lag bolts so the bit wouldn't break. So what I'll do as my first step is I'll basically, tap all these holes, then I can lay down the TTrack.
What a gross day to be outside. Be nice if we could have like a normal spring here in Wisconsin. Okay, so here's the TTrack. I ordered this off Amazon. So what I'm gonna do is have the CNC machine drill the pilot holes for the TTrack, but I wanna make sure that my measurements are correct. So I'm just gonna drill 1 TTrack's worth of holes, make sure it lines up, and then drill the entire surface. So it's just going to complete a circuit here and use that as the 0Z. So the software knows the thickness of the reference bar, and it just adds that to the Z point at which it detects, contact. So this is the software that controls the CNC machine. I have it on one of my older laptops. And yeah, we're just gonna load up this ShopBot file. It's kind of like a cross between BASIC and G-code. It has conditional branching and things like that, which is actually how it makes a decision, to drop the bit until it completes a circuit. So yeah, I'm gonna load up this file and then the machine should automatically start and drill some holes. Okay, we're gonna hit OK. It should spin up the VFD. There we go. So it's doing a surface Z, so it's considering the top of the plywood to be, what was that? Yeah, we had some issues with the bit depth, but that's okay. I'm just looking for the mark. So we see the holes that we made and line the TTrack up, 4 inch on center. Yeah, looks bang on. Oh my gosh, I think I figured out what's wrong. It wasn't how I put the bit in. I reached the lower Z limit. Oops. Well, you know what I can do? I can just use a longer bit or chuck up the bit lower so it has more reach. I'm trying it with a lower chucked bit. This shouldn't be an issue because we're not doing any lateral cuts, just plunge cuts. Let's hear if there's a difference. Okay, yeah, see, that worked. Now it's not reaching the physical end of the Z-axis. Yeah, look how close that mark gets to the end. All right. So much of CNC is just standing around and watching and hoping nothing gets messed up. Oh, so this is my garage. I'm planning to insulate it eventually. That's why I like all these open studs. But it's still a work in progress. That's why I have rollers on my big heavy cabinet, because I'm not sure where I'm going to put it yet. Yeah. But yeah, the CNC fits pretty well. It's a fairly decent two-car garage. So I can actually fit my car in here with all this stuff if I move the good old Ben Heck show table over there. Although I don't usually put my car in the garage. I don't know, the way I look at it is if you leave your car out in the driveway and it snows, that's one less area that you have to shovel. And now it's done and we'll return to 0, 0. Okay.
So once the T-Track's down, I need to work on spacers. So the basic idea is the T-Track adds 3/8 of an inch to the surface, and then we need to make sure that there's enough mass around it that the Sintra top layer doesn't sag. So I'm going to do that with two ways. I have some polypropylene that I'm going to buy from McMaster Carr. So it comes in 4-foot sections. So I've got 3 foot by 4 foot and 2 foot by 4 foot. So on the sides of the unit, I'm going to double up 2 pieces of 2-inch thick for the sides, and then on the front and the back, I'm going to use the miter saw to cut down the 3-inch polypropylene to have a solid edge. So if you look at it, all the edges are solid polypropylene spacing. That's important because if I want to have a T-Track on the side and have it screwed in, it's much easier to screw a T-Track into a piece of solid plastic than it is into the side of plywood or Sintra. Like if you put a T-Track into Sintra, it wouldn't be that great of a grip. But the polypropylene will hold those screws like nobody's business. And then on the inside, between the tracks, for most of the mass, I'm going to use pieces of 3/8 inch plywood from Home Depot because it's very cheap. But we'll use that for the main mass. And then in the middle, there's a good deal of gap everywhere just for margin of error. And you'll also notice in the front, the T-Track actually hangs out the front and the back by 1 inch. That's so I can attach a clamp outside of the 0, 0 point of the machine. If these were all flush to the edge and you had a piece of material up to the edge, it's harder to clamp. You know, you'd be in the same boat as you were before. But like this, you put the T-Track past the 0, 0 point of the machine, then you could add the clamps here and also on the side and also on top. Again, I put a good amount of thought into this.
So here's the first piece of plywood I want to cut for the spacer. Of course it has a bow in it, but I've taken it into account. So I have a tool path that's actually going to use the 1/8 inch bit, and it's just going to drill some tap down holes. So it'll drill some holes into the plywood, so I have a way to screw the plywood into the base. And then those holes are not in the way of the other tool paths to cut out the slits. So basically that'll give me guaranteed safe screw hold down points that will keep the plywood flat as I actually cut the pieces that I need. I've re-Z'd it to the surface of this plywood, which means the Z is higher. You don't really have to worry about the travel as much. And this plywood's basically just being held in place by 1 screw, but since the bit's only going up and down, it's not going to make it shift left and right. So I'm just going to drill a bunch of pilot holes for screws that I will manually screw through this into the base, kind of old school. And then I can cut the main slits themselves. You can hear the change in the sound. And that lets you know if there's like an air pocket underneath. Because if the wood is bowed a little bit, the bit will actually go further than the wood. And then you'll actually hear a different reverb effect because of the air underneath it. So after you cut, 96 trillion different things, you can kind of just tell what's going on just by sound. Okay, I have a whole bunch of wood screws placed into the plywood to keep it nice and flat. And I'm going to change to a 1/4 inch bit and then cut the vertical strips. And then I'll have my first half of spacers. Of course, I have to do this again because there's 2 sets of this. Now you might notice these screw heads stick out a little bit. And that might seem like a problem, but what you do is you set a minimum safe Z travel on the bit. So if the bit thinks this is 0, you set it so it always travels at 0.5 off the surface before it goes down and does anything. That way it clears things like screws and clamps. So I'm taking the width of the bit into account here. So instead of actually doing a perimeter around these shapes, it's just cutting a straight line. Okay, there's the first batch of wood slats. I didn't go all the way down because, as I mentioned, the Z is unknown. See, what you do is you build a table surface, then you have a sacrificial top layer, and then you have the machine mill off, like just the top of that, and then the top of the sacrificial layer is Z-leveled to the actual gantry to make sure that it's correct. That way, if there's any bows in the material, it doesn't really matter. If I pick this up and separate it, I could have the plies split. On the other hand, I don't want to tear up this any more than I have to, or possibly hit those bolts. They're all countersunk, but I'm still trying to be cautious, because if I hit a bolt with this at wood speed, it will break the bit. The cut just about goes to the final ply layer. This is 3-ply. It looks like it goes a little further down on the left side, but probably nothing critical. See, I think I will give this another pass, because the fact that the cut is right at the ply layer means it's even more likely to rip up the ply if I try to separate this. So I think I might just go like 0.5 millimeter shy of 3/8 of an inch. Oh no, I bet I triggered everyone. So this is set to 0.3 inches deep in 0.375 inch material. Yeah, I think I might like go about 3/4 of the way to all the way. So maybe like 0.36, and that should be pretty good. Because I guarantee it is not perfectly level on the Z, which is part of the reason we're making a new table. Yeah, that's going to be a lot closer. You can see the little bits of laminate coming up, being pushed up by the bit. All right, pretty good result. What does remain is basically breakable, just like that. Cool. Look at how much bow was in the middle. Look at that. So you see the bow and the wood messed up the Z, so that part was a little less accurate. Yeah, a little bit there too. And a little bit there. Some bite into our base on the left, not so much on the right, which means the right is a little lower. Pretty good parameter work within. All right, so I'm gonna pull these off, clean them up, make another set, and then we'll work on the Sintra, which is actually the complex part.
All right, the final layer is the Sintra layer, and this, it has spacing, of course, for the TTrack. So your bolts can go through the spacing like that. Not the best. Well, here we go. Oh, look, I'm running into that stupid rotate issue. See, look at that. That wasted me like 3 seconds. So the clamp will hold basically like this, right? And then you'll have the piece up there. So that way you need to have a gap in the Sintra for the TTrack. Then I have all my pockets and my screw points. So I will drill these holes in the Sintra, but then as far as actually connecting the Sintra to the spacer layer underneath, we'll just do that manually. I think we can eyeball this because it's drawn accurately enough that all we have to do is eyeball the edges of the Sintra to the inner track of the TTrack, and it will work. Yeah, all right, so those are the steps. We basically mount the TTrack, put in the spacers, and then put on the Sintra. Who knows what fun times we'll have along the way. And then the final thing we do once it's all installed is we actually have to go through with a milling bit and mill down the first 1/10 of an inch or so to make sure that it's completely level, because the bed might not be completely level, but if you use the big bit to mill everything down, then you know that the bed has been leveled relative to the gantry.
It's like we have a heat map of the table variations. So yeah, we're mucking up this plywood a little bit, but it's actually giving us some numbers, so I can actually drop my dial caliper in there and get an idea of what the max difference is in Z, and then I can use that to decide how much to plane off the final top sacrificial surface. Basically the minimum amount I can plane off of it to give us a nice flat table. Since I'm drilling so many extraneous holes in this base piece, that's why earlier when I drilled the track holes, I labeled them. This is expanded PVC foam. Brand names often include Sintra or Comatex. So this is a 4x8 sheet, and they cut it a lot more nicely than Home Depot cut the plywood. And they even told me what their saw kerf was. That's the thickness of the saw blade. It's 0.19 inches, so I know that this edge, which has the saw marks on it, is was the middle of the sheet. So I'm gonna lay it on the table with this in the middle of the CNC so that I know my left and right and bottom are all factory edges. That way I know I have as much material to work with as possible, since this is now no longer 48 by 48, it's 48 by 48 minus 0.19 divided by 2. Okay, I'm getting ready to do the Sintra. Got it mounted on the table. I'm gonna start with the 1/8 inch bit, single flute up cut, which is really good for plastic. I'm gonna drill all the holes for holding the material down and also for bolting it to the table later on. Then I'll do the pockets and then finally the long cutout strips. There is some danger when cutting with plastics that they will be melted by the rotation of the bit and then stick to the bit. You shouldn't have too much trouble with Sintra. Although, as you can see, since it's a single flute, it's not really pulling the material up out of the hole as much, which is what the purpose of a flute on a bit is in the first place. But on the other hand, Sintra is a lot less messy than plywood, and certainly less messy than, MDF, which is basically sawdust glued into a cake. Okay, now the machine's going to do all the countersunk pockets. Oh, it's like fake movie snow. Okay, got all of the pockets drilled out. Now I'm just going to cut the strips. All right, the first half of the Sintra sheets are cut. I need to label these, number them and the orientation, because the other half aren't exactly symmetrical because the table is not symmetrical in that direction. The amount that it hangs over the edge of that frame versus the rear frame is different. Anyway, so I'll get this pulled off, cleaned up, load up the second file, and get that cut. Oh no, look at all this residue of subtractive manufacturing. That's something you don't have with 3D printers. See, the chips kind of stay compacted inside of the pieces, which in a way can be good because it actually helps support the pieces. It kind of holds it in place almost, kind of like a sandbank. Here are the back half pieces of Sintra that are going to go back there. I now have everything cut, so I'm just going to clean up the table. Then I can start assembly with those pieces and the TTrack. Okay, let's see how this is going to work out. Put this track in place. Doesn't countersink all the way. Probably doesn't have to. So we got one of these clamps. Does it clear the screw head? It does. Well, that's all I care about. Our T-track screwed to the plywood base. Then on the sides, I have 2" by 3/8 polypropylene. Should be a nice stiff spacer for the sides. And the reason I have this on the sides is so we can screw into the side of it, which you can't really do with plywood. So we can put a T-track here as well. Got our wood spacer, which goes about like that. There's also gonna be a piece of polypropylene here. Sintra will sit like that. Like that. So to you just do a material Z then all the time? Like that? You just do a material Z all the time?
The only thing we're going to be dependent on here is the accuracy of this table.
So this is the TTrack that's going to go on the side of the CNC machine for maximum clamping options. Oh yeah, that's looking great. As long as the corner 0, 0 is, that's what really matters.
I know.
So we just want to leave that there, huh?
I mean, is it going to be in the way?
No, it makes sense. Yeah, you're right.
Prettier. It won't really matter.
It's pretty cool. I'm gonna put down some more of this Robin Hood wood. I am Robin of Locks.
Where are the fancy hand screws?
Oh, you have a box right there.
Oh, right. Oh.
The ones labeled
It
Centra.
was too damn.
Mm-hmm.
Oh, I need to sand this.
Well, the screws aren't long enough to get to it, so don't worry about it. I did take that into account. So how dumb of an idea is it to like make cabinets from scratch? On a scale of 1 to 10. Although PVC could probably absorb water.
I bet you the polypropylene probably expands more than that'd be my guess.
Polypropylene is like food safe plastic, right? It smells like a cheese factory.
Yeah.
I'm going to use a knife toward my my wrist while drinking.
Brilliant.
Pretty good here. How are you?
That's perfect.
Okay.
Oh, geez. It's party over.
Wait, was that yours or mine?
That was mine.
Ha ha! Look at that!
Damn it.
Okay, so now it's time to mill down the surface so I have a surface that is flat relative to the gantry. Yeah, here it's lowest in the middle and a little higher on this end, much higher on that end. So that was 030, I'm gonna go 040. Okay, that's 040. It came really close, but not quite. Okay, I found the number. It's
0.09 inches or 90 mils. It's kind of extreme for the edges. You can definitely see how much it's taken off, but the middle was definitely the lowest part. Well, I have a number that I know will work. Time to start the messy milling process. At least though, it's Sintra, so it's going to make a less horrible dust than MDF would. All right, it's done. Now we just have to clean up this horrible mess.